I'm Dan O'Mara here with Circuitlaunch, and would just like to welcome everyone here. Tonight we're going to be doing a speaker panel and talking a lot about getting into robotics. If everyone could please keep the conversations to a minimum while we're speaking, because it's very hard to hear even if you're having conversations in the kitchen. Hope you guys enjoyed the Brazilian barbecue. It's one of the things that we're known for. Welcome. Thank you. I'm going to hand it back to Kyle, and he's going to give us talk a little bit about the Hardware Collective, and then we'll start up our panel.
Thank you, Dan. So really wanted to make a couple announcements. So the Hardware Collective, we meet every month. This is one of a year-long series that we're just doing every month at different locations around the Bay Area. So Circuitlaunch is gratefully hosting this month. Next month, we're going to be in SF at a place called Studio 45. Month after that, we'll be at a location called Port Labs in Oakland, California. And we just keep the rotation going. We have a great series of companies. There's an incubator called Silicon Valley in Your Pocket that also partners with us. So every month we have an opportunity. And last but not least, we want to thank one of the reasons why we're able to do this is our sponsor, Kickstarter. And so they've gratefully provided funds to give you guys the food and beverage today, as well as a reason for us to have these great speakers and presenters. So again, thanks everyone for coming out. Let's get this panel started here.
Great.
Jeff.
Thank you, Kyle. All right, so again, welcome. My name is Jeff Frick. I'm going to host the panel. I've got a company called Menlo Creek. Check it out. It has nothing to do with robotics, but that's okay. But we're excited to talk about trying to get into this business. It's going to be tremendous amount of demand in terms of the need for robotics and then the people to manage the robots. And there's just not enough people. So there's a real opportunity if this is something of interest. You know, that basically I think the world is your oyster and there's a lot of different paths, so I'm excited to learn more. So we've got two great panelists. You've already heard from Dan O'Mara. He's the COO of Circuitlaunch here and also COO and the founder of Mech Labs. We'll have him kind of break down the difference between those two because I think it's important. And to his right is Andra Kay. She's the managing director of Silicon Valley Robotics. She's also an advisor here at Circuitlaunch, and she's got a laundry list of advisory positions on her LinkedIn that I chose not to print. I don't have enough paper at home. I don't buy that anymore, but a real veteran in the space. So we're really excited to have her as well. So why don't we drop in with you, Andra? You've been doing this for a long time. You're involved with a lot of companies. Give us kind of the overview of what's happening in robotics. Has anything changed kind of coming out of COVID in terms of prioritization? We know labor is tight and it's going to continue to be tight. Can the robots help us out?
Absolutely. And that's a great question because that's very much front of mind at the moment. We're in the middle of Dr. Gil Pratt, who led the DARPA Robotics Challenge, called it a Cambrian explosion in robotics. And since 2010, we have seen incredible variety and scope in the robotics industry. Now, the problem 10 years ago was new robotics companies searching for the market. The problem post-pandemic is that the market has decided that they need robots. They need robots not just for last mile delivery of their Amazon orders, but to replace absent workers in factories and fast food joints, to replace absent workers pretty much across the board, assisting with nursing staff in hospitals, for example. And that was a major use case for robotics during the pandemic, as was having robots to help put together COVID testing kits. You imagine how tedious it is putting a cotton swab into 50,000 packets? Okay, now robots excel at something like that. And the problem right now is that there are simply not enough robots out there. Now, if you happen to be in a startup, a robotics startup, or have had recent experience of that, it's not smooth sailing. At the same time, we have never had greater demand for robots. And it's never been harder for a small robotics company to find funding and to grow. And one of the other challenges is addressing that. But we certainly see a market that wants robots now.
Why don't you think the funding has followed pace with the anticipated demand?
Well, very few people are, how would you say, fluent in robotics investing. What we're seeing is a general downturn in the investment community. So money dries up, and it dries up all the way at the top of the money tree, where the limited partners, the family offices, the funds, the pension funds, they make fewer investments. And they certainly, and here's the thing, they move to making conservative investments, even when it's absolutely not in their best interests. For example, you would think that pension funds from the health industry would realize just how much assistance is needed and would be prioritizing getting that, investing in results-oriented companies. But there is this gap in the middle where they make financial decisions, they appoint their money to VCs who don't necessarily have a vision or fluency in understanding this new environment of robotics. What I will say, though, is that many of the more major players that used not to be involved in startup investing, and I'm talking about your hedge funds, they used to be all about the stock market, and then they were interested in the SPACs and the IPOs and the reverse IPOs. And then they looked around and they said, we recognize this asset class. You're putting out like utilities. You're putting out hardware that is going to be essential, and people are going to keep using it. And we understand the time frame in which you're going to have a return on investment in this. So we're seeing markedly new players in the investment landscape. Not enough, but I think, it means that the smart investors are still very interested in robotics.
So the lesson is you're an AI company that's packaged in a robot body when you go to your investors, because they'll invest in anything that smells of AI. Dan, to you, let's talk about, kind of what the traditional education paths have been, and how those are not really keeping up. And then specifically for the people that aren't familiar, what you guys are doing here specifically at Circuit Labs and then at Mech Labs as well, which I think people is a little confusing. So walk us through how you guys are addressing the need.
Sure. So just a brief introduction of for those of you guys who've been to Circuitlaunch, you understand this is a community here of amazing roboticists, electronics, hardware specialists, hobbyists, all levels of that. And that's really what we've tried to build here. We're going into our 6th year of being open, and this community is vibrant. We're about, 98% of us, of the businesses are here, are all into hardware and electronics. So we've built this community because there's a need, and there's these people who are infinitely passionate about it. And we kept getting the same question: how do I get into robotics, right? How do I do this? And this question didn't come just from people who were who wanted to career change. They came from people in robotics companies. They didn't know how to do other things in robotics companies. So there's so many employers out there right now. It's like, I need a skilled robotics technician. I need automation engineers. I need all of these people. And so they put out a call for like, okay, I need, 6 years of schooling. I need someone with a master's degree or higher. I need 3 to 5 years of robotics experience. But how do people get that if they don't know how to get into robotics? So, originally our answer was, well, you go get a computer science degree, a mechanical engineering degree, an electrical engineering degree, and maybe an MBA to be good. Wait, that's a lot of school. Nobody did that. Nobody in our community has done that. We have electrical engineers and we have mechanical engineers, and some of them are brilliant. Not to say that education isn't worthwhile, but what they're doing and what they're learning is not from school. Schools are not teaching what people need to do. And robotics is moving so fast that the moment that something is done, you can't even write it into a textbook fast enough. And so everybody here basically said, I'm going to build something. And they learned how to do it. Face it, we live in a world where you can learn anything on the internet, right? But there are those challenges there too. Like, how do you find the right things? What happens when you don't know something? How do you look for it? What's the jargon? Where is that? How do I get mentors? How do I figure out this thing that everybody else figured out, like FCC certification? And that's where this community really came through. And my background, I'm not an engineer. My degree is in ethnobotany. It's a study of uses of plants by culture. And so, but one of the things that I've done a lot is I've learned, I was a tech shop instructor. I created my own product and got a patent, the Ninja Standing Desk, which is a portable standing desk. And I jumped into this community knowing very little and seeing how everybody else learned. And you know how they learned? By building it, by doing it. And right now, getting hired, how do you show that? And how do you get that experience? So that's when Mech Labs was born. Mech Labs is a build it to learn it education program for mechatronics. We say no textbook, no curriculum. Let's just choose a project and build it. And then you are going to learn all these skills, and you're going to know what you don't know by failing and having problems and understanding. And then a peer group that includes electrical engineers who are learning programming, and you have mechanical engineers learning, electrical engineering. Like, you have all of these people who are all experts coming in, and we all help each other. And it was amazing. People came through the programs and they were able to shift careers. They were able to get into, they were in one very small vertical of a company, because face it, corporations love to find what you're good at and keep you there. While that's great for them, that's not really good for me. I get bored way too easily and I want to do new things, right? I don't know about any of you guys, but so people join Mech Labs to be like, well, I'm a QA in a robotics company, but I would like to do technical stuff. Or I'm an embedded software engineer. I would like to design PCBs. And so that's really what the whole program was built for. And we've seen so many people. So we're really trying to be that kind of alternative education for engineers and be able to give them hands-on experience with real things, unlike internships and unlike degrees. And it's been fantastically successful. And we're going to be expanding here even more, which we'll talk about in a bit.
So from a skills point of view, from somebody coming in that's not familiar with robotics,
yep,
right? And from the outside looking in, you see the mechanical part, you see the software part, you see the electrical part. There's all these different parts. Where do you find is the easiest place to come in? Is there an easier place than another? And you're also talking about all this kind of cross skill, kind of training and leveraging. Where do you find most people coming into it new? What are some of the skills that really shine that they can take it and run?
Yeah, I mean, don't get me wrong. Everybody's going to come in a different place, right? And there is a lot of skills to learn in robotics. For those of you guys in there, you know how much it is that you have to learn and how much we all don't know, right? So instead of saying, hey, I need to let me go look at a bunch of job listings and see what skills they want, and then I'll train in that, right? I mean, that's part of it. That's a good start. But it's really about, what are you passionate about? And what do you want to start building? So when we get a new student in our individualized program, which is where we put in someone to choose their own project with our help based on their learning goals, that's what we're doing. We're also expanding that to where AI will be able to help actually do matching projects and skills and everything, where instead of saying, hey, what skills should I start with? What project should I start with? That's really it. And what do you want to start with? And so we as advisors in Mech Labs and using AI and a lot of our tools, we're able to give them a project that starts them. And then it's no longer what skills do I have to need? And it's this overwhelming thing of oh, I've got to learn it all. How do I do that? What skills should I start with? It's like, no, where are you at? What do you know? Let's just start with something. Do you want to drive, start an autonomous RC car? Would you like to do robotic arm path planning? Would you like to do these things? We can create a project for you. And that's where I think the real focus is. It's not learning skills, it's learning how to learn.
That's great.
I would add to that and say, it isn't so much about the skills that you learn, the skills that you start with, or the skills that you want to pick up and excel in. It's about demonstrating that you can put things across different skill sets together. And this is where robotics is such a highly demanded skill set. It is because if you've done any work, whatever your specialty is in robotics, you've had to deal with complex integration. And this is why the biggest competitor that most robotics companies have for recruiting talent is Google and the other software giants. And it's very disappointing for many really great roboticists that get jobs there because they end up doing search or ads or something. And you're kind of like, so where did the robotics fit into that? And it is exactly because you've demonstrated troubleshooting, holistic skill set, and complex problem solving and integration. So just extending on what Dan said, it's about learning how to learn. Robotics is the best challenge you can set yourself because it is the most both fun and interesting, but also the best technical challenge that you can be setting for yourself. And I think the fun is a really important part. It doesn't matter what robot project you build. Have fun, build something you like. You're getting the whole experience as part of that.
I mean, most of the companies here are fascinated with the technology that they're building. You know, everybody comes in and says, you know, well, what do you do about IP theft and all of that? I'm like, everybody's too excited about building their own thing to steal yours, right? And I had another point of thought where if we are going into the AI age, we are going to be changing the way that we identify as human beings. If we've always been the tool, like the keepers of knowledge and the gainers of knowledge, right? If we actually end up being in a place where AI is the ultimate source of most of our knowledge, where is the identity of humans going to be? It's going to be in building things. It's about putting them together, because AI will not take over robotics, because it might be able to tell you the next step, but you are going to have to build it. You're going to create it, put all of these disparate things together and make it work, problem solve, and troubleshoot. And no AI is going to take that away from anybody who's in robotics field.
No, and the robots can't open doors yet, right? So we've still got a little bit of leverage on them, although they're getting better. Andrea, I want to talk to you about, kind of what the reaction is to the skills shortage so that people know how to get in terms of both formal education programs, are they addressing it? Sometimes we often see in community college type programs, that they can kind of react quickly to build things that are in demand by the employers. And then finally, the employers, this whole thing of, if you can't find the skills, you hire for attitude and then train the people. How are you seeing them respond to this lack of talent?
Well, I am a huge fan of community colleges and that practical-based application, and really meeting people where they are as students rather than setting a ridiculously elitist bar for where we can charge you a lot of money. And one of the big weaknesses of the US system is not having, maintained that superiority in technical fields that some other countries did. A great example is the way Germany adapted the apprenticeship model and incorporated that into high demand education. And the apprenticeship model is a far better fit for a lot of the new technologies that are new materials, new methods, and hardware, new machines. Now, what we do, because we don't have good education there, and believe me, I am aware of a lot of the federally funded initiatives, but a lot of money goes into pilots at a single university somewhere that are then expected to magically spread across the rest of the country, which doesn't have the funding or incentive to take them up. They want to apply for funding to create their own course. I have seen far too many funded courses that are just repeating the same information. Really, how we're doing education in robotics is pretty broken. And that's really sad, because the people involved in it, both as teachers and as students, are passionate about doing this. And I don't think it's the best experience for anybody. But beyond that, I think it isn't just the community college or the apprenticeship model. To meet that gap, many companies are saying, look, we've gone through all the computer science graduates and they just don't have the kind of hands-on experience we need. And we've looked at the people that have got lots of skills from other areas, and they don't have the ones that we exactly need. So again, we're going to hire for enthusiasm, culture fit, even though that's a bit iffy, or something else. We're going to hire someone who can learn, and then we will invest in training them for 3 months, because otherwise we know that they will not know what they need to be doing in our company. Now, we do have opportunities, and this is where I think the Mech Labs program is an incredible opportunity for us to scale that model. And for example, I think Dan's going to talk a bit more about the next project around palletizing with a particular robotics arm that can be extrapolated across other robot arms and similar skill sets. Now, we no longer, it's not going to be then down on one warehouse company or one robot arm company to develop the education. Customized education can be done through Mech Labs, but then scaled using this combination of virtual learning, AI assistant, and hands-on lab-based building. And I think that's the sort of thing, you know, we all got excited about Maker Labs, didn't we? Okay, and there was a lot of this promise that we're democratizing learning in the physical world, but it became a place where if you knew how to build something, you had a great time. If you wanted to get into building something, you just had to hope that someone would run a course, because you were just left on your own devices. And we're ready for a disruption in how we scale hands-on learning.
That was a great segue to talk about Dan's new toy in the back. I'm surprised we didn't wheel it out here, but maybe it doesn't wheel very well. Talk about the new big blue arm in the back and what you got going on there.
Yeah, so if you guys get a chance, you'll get to take a look over there, the Doosan industrial robot arm. It's really quite an amazing thing, but the story behind it is really what was kind of exciting for us. Is that so we met this gentleman who had done a decade of sales in automation engineering. You know, basically, if you have a cereal box, there is a machine that took the box from a flat side into a fully, box size and glued it, and then it fills it in. It's old factory automation that has been around for forever. There's a lot of advances there too, and there are great opportunities in automation engineering. But he saw a very specific thing, which was a palletizing robot. Before a box comes off a conveyor belt, somebody has to pick the box up and then bend over and put it on a pallet. And then they have to reach over that box and put the pallet, the next box on there. And they have to do that. And then you can use a pallet jack or something else to be able to move it. But there's this thing that, like, I got to move a box from here to there using a human. And it's just the most, like, if there's one job to completely replace, I'm sorry, that's a good one. It's so hard on people's body.
I know robot companies that have hired people for the summer to move boxes so that their robot can practice on them.
Yep. And so we flew out to this company called A2020, which is sponsoring our upcoming course, which I'll talk about. They had this problem. They couldn't hire anyone. Their main technical guy, who, when he called it technical, we looked at his designs, and I'd say that 90% of the people in our community, if not 100% of the community, had a much higher level of technical expertise, even our makers, honestly. And so they designed this arm to be able to palletize these boxes, and he couldn't, that person left, and he's left with this amazing arm. He has 5 more of them that he can't rent out. He can't even sell because he can't hire anyone. We flew in to talk to him about doing a custom program for him on training people on that arm. And as well, of course, we're going to be able to give a robotic arm technician training so that anybody can learn that. But what was the opportunity, which was really interesting, is we actually had one of the person he did hire. He had them come out, and I asked him a lot about his experience. I was like, do you have any programming experience? He's like, no. It's like, do you know Python? Do you know any? He's like, no. I was like, okay, have you programmed PLCs before? He's like, I've wired them up, but I haven't actually programmed them. I was like, okay, you've assembled and set up. He's like, yeah, I helped with that. And then it's like, okay, well, what do you have for experience of pathing, like actually designing the arm's movements? And he's like, well, I worked for a company that had a software that did it, but their software started failing. So before they went bankrupt, they were just using the teach pen for the robot. And he got hired for $120,000 a year. That's the state of robotics arm engineering. But go try to get a FNUC, training. They do have them. You can go there. But I went and looked. It was hard for me even to find prices and times. You had to contact a salesperson or whatever. So we were like, okay, this is ridiculous. We need to train people there, because in 1 month, we could be able to train someone far more experienced than what he had, be able to jump into a career that is in demand, that people are needing, and that is very high pay. And the technical skills are not that hard. Even if you don't know Python, you've never wired together a microcontroller, all of the things you think are basic are robotics, that stuff we can train. So the project that we're going to be doing, it's, and I don't know if Noel can actually put this up. Yeah, there we go. So these are our programs, and we're going to do the robotic arm technician training. So it's going to be 1 month, and we're going to be able to train you to be able to go through all the things to set up this arm, how to wire it, how to program a PLC, the safety, pathing, and everything. And then the AAA 20 group is going to hire and follow some of our students, is going to evaluate and possibly hire some of our students directly out of there, because they need technicians. And not only that, if you actually do go through the program, we'll be giving the micro certification of and showing how you earned that by all the project and all the work that you've done by the documentation that you do on this arm. And then just for an extra thing, we're going to do a Tetris bot. We're going to actually run some Tetris pieces, some large size Tetris pieces down the conveyor belt, and we're going to program it to be able to make a perfect cube on that. So that's our stretch goal for those who have a little bit of programming experience or want to be involved in that.
And how much of those skills will be specific to that model and unit versus generalized to robot arms or beyond arms in general for people taking the class?
When we walked into there, we saw what they had problems with and what they were, and it's the Doosan arm, but all of the things that they needed help with are across it. Like automation, they use old school manufacturing techniques, the old Allen Bradley PLC that uses ladder, and that stuff is very easy to learn, easy to set up. And those skills are going to have wide range from whether you're using a FNUC or anything else. And it's a cobot, which is also in demand for understanding how to use. And most factories are updating to cobots so that they're safer and easier to train.
Not only that, but the robotics industry itself is advancing rapidly. So you do have the old school PLC controller-based robot that now you have middleware layers. So, for example, Siemens doing a robot, I think they were calling it Robot Operating Studio, but it has been made to be compatible with all the major ARM makers so that you can supersede the specific PLCs that have been limiting for so long. And then you look at some of the newer robots where they're natively programmable over your desktop or remotely. You don't have to be locked into the PLC. That's just not the way that robots today, on the whole, are getting made.
I mean, honestly, that little robot, the Arduino Brachio ++ that we have over here, but it's part of MechLab's program, you can do that too. That is far more complicated to use than this thing. It really is amazing. It's like these skills are easy. And then again, to hammer that point, we're teaching these skills through a project, but what we're really hoping to do is teaching you how to learn how to learn.
Right, right. Andrea, another thing you brought up before we went live and everyone is enjoying the barbecue is that there's other jobs in robotics companies and in the robotics industries that don't necessarily need the skills that you're teaching people in this ARM class.
I am on a mission to poach everybody else's employees, okay? Because when you think about it, we're growing so many robot startups here, and they start as 4 people who are largely very mechanical and software oriented, and a driving CEO who's got plans. And then they have to take on some senior hardware engineer, maybe manufacturing engineer, maybe Q&A. a software team, some managing people, some, oh, time to bring in HR and accounting and operations and ops. Now we're into, we've got customers. You know what ends up being the largest department in a growing robotics company? Sales and marketing. And, oh yes, we have sales and marketing robotics expert there. Chris Matthews is a guru, and he wrote the book, literally, I've got a copy of it in there, telling the world about how to market a robotics startup. And that's the thing. I want to tell you, it doesn't matter whether or not you want to hands-on build robots. You can be part of the most exciting career, part of the technology of the 21st century, building the future. We need everybody in robotics.
How many of the robotics startups that you see are attacking a specific problem from the application side, or is it more a problem from the robotics side that then hopefully we'll find some applications for down the road?
To grow, you have to get to a real problem as fast as possible. And one of the things is that many early companies underestimate how complex a solution for the problem is, in that it has to not just say, look at this wonderful robot, it will do X and solve your problem, because the way that that company has historically done X might have been controlled by people, might have been controlled by software. They might have no way of monitoring whether or not it's been done properly, or it might need to integrate into a very large CRM and order system. So they don't actually just want that wonderful machine that does X. They want to have a solution integrated into their problem. And that's where there is still so much open space in finding big, juicy problems that you don't need to become a custom systems integrator where every project is different. Not that there's necessarily anything wrong with that. If you were reading the news today, you will see Amazon has launched Cobot, which is their team to do custom robot integrations for customers, because they have so much inbound. Guys, you know everything about using robots. No, they don't, but okay, they've got a good idea. Please get robots for us to do X, Y, and Z. And each one of those is a custom solution. At the same time, you have other robotics as a service companies who are going, okay, we're going to specialize in finding the 20% of your problem that 80% of companies have. We're going to build that, and then we're going to do it there and there and there and there. So they get really good at creating a work cell in a box that can be easily programmed online or remote operated or something that meets some very significant needs and is a broad enough problem to be a really great business idea.
So Dan, when somebody comes in and they want to get in this, I mean, it's one thing to say you just got to be great and problem solver and creative, and we'll put you on the arm and you'll get it figured out. But is there an easier way, a more specific way to try to enter in? Say you've seen some robotics companies, there's a ton in the Bay Area, and you want to get in, and you don't necessarily, you're not a roboticist. Mm-hmm. What are some of the ways that you know that you're going to touch the nerve that's going to get them excited to give you an opportunity if you don't necessarily come in with those skills? What are some of the attributes that you should highlight that says that you're going to be successful even though you don't necessarily have the skills?
Care about the problem that they're solving. So one of the first questions that I ask someone who comes to me and says, you know, they're finishing their master's, they want to get into robotics, they don't know where to start, I say, what do you like doing? Okay, because if you hate going outside, then agricultural robotics is not for you. If you really want to solve the global food supply problem, then agricultural robotics is absolutely where you fit. And if you show up at any company saying, I love the way that you are solving this problem, and I can see and understand why that's important, then I think that supersedes your skill sets.
Very much so. I think following your passion is kind of what Silicon Valley is really all about, I think, a lot of that stuff, and robotics especially. Like, we all learned robotics by getting excited about a project and starting there. So that applies to whatever skill level you're at. I mean, we have people who come in who are just complete beginners, and we start with, okay, here's a little Arduino and a couple motors and a sensor, and let's make a line following robot. And that may take them anywhere from a day to 6 months, but that's up to them, right? And that's the great part about the program, and what we want to get them excited about things and be able to do that. The program itself puts organization and helps people grow, and then puts them around all of our mentors, which are amazing, amazing companies to help get them to the next step. But the skills and attributes that I see that really help of like learn to learn is the willingness to fail and explore, right? I teach CAD, I help all these people, and very much of just in a way of, have you explored this, right? And most of the time they haven't explored the menu, or they haven't explored things like that. And I see that that's a lot of the part. It's that the people who learn the most are the ones who are willing to like, well, let me just push a button and see if it works. They don't have to know the full skill set. They don't have to do. It's like, oh, I want to make a PCB. Well, how do I do that? I don't know. Let's just wire some stuff up and see. Like that feeling of not being afraid to fail, and then not feeling this oppressive feeling of like all of the education out there that you need to do this simple thing, right? Robotics it's very complex, and it's very deep, and it can be very hard, but it also can be so satisfying and so easy in many ways, because there's like $5 microcontrollers that are, 50 times faster than what the original Arduino was, that you can get on Wi-Fi and, Bluetooth. And now you have AI to be able to tell you how to be able to wire it together. And then, you join a community. But it's the willingness to explore and experiment and say, oh, there's so much to learn, and let that stop you. Or you say, you know what? Let me just go do it, and I'm going to learn along the way. I'll learn what I don't know for sure. And then along the way, I'll learn what I'm interested in and get there. And that's when we see people gaining those skills, whether they're in a vertical of robotics already, in a company, or if they're a software programmer and wants to get into robotics, or any level of that. I think that willingness to explore and fail and then build something so that you have that on your portfolio.
Right. That's great. So we are going to have a question. So if anybody wants to queue up for the questions, we've got a microphone set up over here. So if you can just make a queue, that would be great. And just time check at the top of the hour. We'll do the speed dating. So as we get closer to that, so if any questions, come on up. Andre, I wanted to ask you, kind of on the expansion of what robots and robotics is. I think for a lot of us to see things like Roomba is probably, I don't know, the biggest selling consumer robot that's probably out there, or to see, an Amazon distribution center and the way that those little package movers move. How has that really changed kind of the opportunity and the TAM to see, what is a robot, and where can we apply this combination of software, hardware, mechanics to solve problems?
That's a great question. And I think it actually leads to understanding what the price of a lot of the units are. Similar to what Dan was just saying about how much computation, and not just computation, but computation that is kind of preloaded to be really useful, to connect to things automatically. You can get for $5 now. I love the Roomba. I've been a huge fan, and we actually have one in our Museum of Social Robots. And you might think that this is a toy collection, but it really relates to price. Some of the best, 15 years ago, the best robot makers were either building multi-million-dollar robots, like the Canadarm on the International Space Station, or self-driving mining trucks in West Australia, giant, really expensive robots, or they were building toys. And toys was really the leading edge of working with miniaturized components that were affordable, because I can guarantee you the price point for a successful commercial toy has got to be very affordable. And so we can see this evolution between robots that were toys in the image of the robots that we wanted to build, to being toys that were demonstrating aspects of the robots that we really had in the world, to actually being miniature useful robots in their own right. And our museum has been left to us by the late Joanne Pransky, who I'm sure just about everybody in robotics knew Joanne, and I'm sorry if this is the first news that you've had about her passing earlier this year, but her friends and family asked Women in Robotics to put together a scholarship to support women and underrepresented people getting involved in robotics, because Joanne was passionate. She was one of the first, I think she was the first female sales engineer for industrial robotics companies. She founded the first medical robotics journal. She was in robotics before I was, and she never lost her passion and her excitement. She loved seeing new robots, and she billed herself as the robot psychiatrist, as in the I, Robot stories by Isaac Asimov, and one of her prized possessions is the Asimov autographed photo to the real-life Susan Calvin. But, you know, that's just to let you know a little bit about how really meaningful this museum is to many of us, and to encourage you to, well, the goal with this is to support people who weren't otherwise thinking about robotics go in that direction. And that's the message that we're giving everybody tonight.
I mean, the market is just behind. I mean, this is a very special place. I've been here a bunch of times. The labor shortage is systemic across all industries. There just aren't enough people. So to have an opportunity to come to a place like this, to have people to leverage and ask questions and play with the big blue arm, it's pretty special. And there just aren't enough opportunities for people to get trained up to take these jobs. So good job for you guys. Give you the final word before we kick it over to speed dating.
Yeah, absolutely. I do just want to add something to how does this work as a job fair, okay? When the pandemic happened, we really shifted at Silicon Valley Robotics from doing in-person job fairs to doing online job fairs. And that has remained a really important part about the job fair environment. If you didn't load your resume up to our resume database, the URL is on the notice board. It was in the event invitations, and you could do it tomorrow. You don't need to do it now. But most of the hiring companies have either posted a job online or reached out to me and asked me to send them the resume database. If there are any hiring managers here right now, you're going to get mobbed. But even if there aren't many here in person, I can guarantee you that there is strong interest in having a look at resumes. And we're going to be building on this online matching with the help of some AI so that we can do a better job of finding the right company for your particular skill sets. And I'm looking forward to developing that. So that was just to explain a little bit about the online job fair and the in-person speed dating. And also to say my colleagues are here from the IEEE Robotics and Automation Society. And we're going to be available to, if you're interested in learning about what IEEE is or what the IEEE Robotics and Automation Society is about, and some of the other events that are going on. Silicon Valley Robotics, Open Robotics, and IEEE RAS are co-hosting on Tuesday night, where it's Women in Robotics off the clock with Women in Robotics at In Orbit in Mountain View. So for all the women here, that is a really great way to get networked with the robotics community. And on Thursday, it's Ross by the Bay with Kat Scott from Intrinsic and Open Robotics talking about the latest ROS 2 community updates, and Eric Chen from UC Berkeley talking about Fog ROS. which is, you know, you've heard of cloud. Okay, well, when we're talking about devices, it's a lower layer. It's fog.
Dan, any final parting shots before we kick it over to speed dating?
I just want to thank you guys all for coming out and be a really, I'm so happy to have you all here and to be able to have you be in this part of this community as well. I would be amiss to plug the Mech Labs program that we're doing one more time, the robot arm technician training. If you actually sign up for it this weekend, you don't actually have to pay. You just have to sign up for it. But you'll get the price, which is, I think, $300 off for it. So sign up. And if you do have questions or anything like that, please let us know, and we'd love to tell you more about the program. And we'd love to get you trained and get to play some Tetris with a giant robot arm. Come on, how's that?
I'm just curious, show of hands, how many people are formally connected right now with Collective? Not too many. So new opportunity. So hopefully this is a great exposure for you to see a pretty cool place. Now you're going to have some time for the speed dating and also to hang around and see what's going on. It's a pretty unique situation that they've got going on here. So it's pretty cool. Alex and Dan, the team, big shout out for Pat. Hopefully he gets better. Great job. So thank you very much. Let's get a hand for the panel.